Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over some problems dealing with unit conversions, unit calculations. So let's get into this. So I'm going to go over several problems, maybe, I don't know, as many as I can get done in this video. So I'm going to show you in each of these problems the steps to go through to solve or do a conversion factor type problem. So again, the thing that you want to do is two things. One, any conversion factors that are in the problem, pull that out and identify what the conversion factor is. And two, figure out where you're going to end and where you're going to begin. Okay, so let's get into this. So for problem number one, we're told that the diameter of a proton is 2 times 10 to the negative 15 meters. Okay, and then the question is, what is the diameter in, that should be nanometers. They give us meters. They want to know how many nanometers is the proton. Okay, so there's no conversion factors in this problem, but they do give us the the size or the diameter in meters of the proton. So we're going to have to use that. So when it comes to conversion factors, they're giving us meters. They want nanometers. So where are we going to begin? So remember, you're looking for the question. 99% of the time, the beginning of the question tells you the end of the problem. So here we have the question. What is the diameter in nanometers? That's where we're going to end. So we want to get to a certain number of nanometers. We want to convert to nanometers. We need to begin somewhere, and so that's either going to be in the question, like I said, 99% of the time it's going to be in the question somewhere. If it's not in the question, then it's somewhere in the problem. And the only thing that we're given is the diameter in meters. So we've got to start with that. So you're looking for a problem. You're looking for something in the problem that isn't related to anything else. It's just kind of there by itself. And so 2 times 10 to the negative 15 meters is what we're going to start with. So we want to go from 2 times 10 to the negative 15 meters, and we want to convert that to nanometers. So let's go ahead and get started. So we're going to start with meters. So we have 2 times 10 to the negative 15 meters over 1. And we need to convert that to nanometers. Now, we're not given any other conversion factor, but we should know our metric prefixes. We should know the metric unit conversions. And so we're going to have to use that. So meters to nanometers. So we need to know the relation between meters and nanometers, between the base unit and the prefix unit. So in this case, we need to know that nano means 10 to the negative 9, or 1 billionth of a meter, 10 to the negative 9. So if we know that 1 nanometer is equal to 10 to the negative 9 meters, we could use that as a conversion factor. So let's go ahead and use that. So I put meters on the bottom to cancel out meters. So I have 10 to the negative 9 meters on the bottom, and I'm going to put 1 nanometer on top. So the meters are going to cancel out. Now we have nanometers. So you might be wondering, well, how did I figure this out? Where did I get this from? Well, the key is in knowing what the prefix means. I always put the 1 with the prefix unit, and then whatever the prefix multiplier is, I put that always with the base unit. So 1 nanometer, nano is 10 to the negative 9. So I put 10 to the negative 9 with the base unit. The 1 goes with the prefix unit. So that I know I set up correctly when I set it up that way. So now all I need to do is multiply and divide, and I get my answer. And in this case, it would be 10 to the negative 6. So it's going to be 2 times 10 to the negative 6 nanometers. And again, if you remember your rules for powers of 10, right? So if I have 10 to the negative 15, and on the bottom I have 10 to the negative 9, so I'm dividing these. So if I divide by two tens to different powers, I'm going to subtract by the bottom one. So negative 15 minus negative 9, that's going to be 15, or negative 15 plus 9 gives me a negative 6 for the 10 here. Convert for sig figs, when you're multiplying and dividing, the rule is that your answer should have the same number of sig figs as the least number. This is exact, so we can ignore that. So we have a 2 here. That's one sig fig, and then we have one sig fig there. Okay, let's move to the next one. So the mass of an electron is 9.1093897 times 10 to the negative 31 kilograms. What is the mass in nanograms? So again, very similar to the first one. We're not given any information except for the mass of the electron in kilograms, but they want that in nanograms. So we want to go from kilograms, and we want to convert that to nanograms. So just like in the first problem, we're going to have to use our metric relationships, our metric unit relationships. In this case, we are going from a base unit to a prefix unit. So whenever you're going between base unit and prefix unit, then you can use one conversion factor. But notice here, we're going from a prefix unit to a different prefix unit in the metric system. So in this case, you're going to have to use the base unit as a medium between the two prefix units. So you got to convert to the base unit and then convert to the other prefix unit in 2 steps. Or you could use King Henry died by drinking chocolate milk. You can use that mnemonic device to move the decimal point in the right direction. But I'm going to show you how to use the conversion factor since that's what we're focused on. Okay, so we're going to start with the kilograms they give us. So 9.1093897 times 10 to the negative 31, and that's kilograms. Now kilo, I know kilo is 1,000, so 1 kilogram is equal to 1,000 grams. So kilo is 1,000, so 10 to the third grams. So I'm going to use that to convert to grams. So 1 kilogram goes on the top or on the bottom to cancel out, and then 10 to the third, or 1,000 grams, goes on the top. So kilograms cancels out. Now I've converted the metric unit, the prefix, sorry about that. So I converted the prefix unit to the base unit. So now I'm going to convert the base unit to the prefix unit. So now I need grams to nanograms. So again, nano means 1/1 billionth, or 10 to the negative 9. So 1 nanogram is equal to 10 to the negative 9 grams. So I can use that. So grams is on top, so I'm going to put 10 to the negative 9 grams on the bottom, and 1 nanogram on top. So grams cancels out. and I've got nanograms. Nanograms is what I want, so now I am done. And oops, that should be an equal sign. And now all I need to do is multiply by the top and bottom, get my answer, and when I do that, I get negative 19. So it's going to be 9.1093897. Oops. 97 times 10 to the negative 17 nanograms. And so that is our answer. Again, our answer should have the same number of sig figs as the least number of sig figs in the numbers that we're multiplying and dividing. These two relationships, these are exact, so we can ignore those. So the number of sig figs here is going to determine the number of sig figs here. So it's the exact same number of sig figs. Let's go to the third problem. So here, we're told that there are 4.070 times 10 to the 6 pounds of sulfuric acid used to make Jell-O each year. We want to convert that to kilograms. So we want to go from the pounds we're given. So we're going to go from pounds to kilograms. That's what we're asking. We're told to convert to kilograms. So we got to start with pounds that they give us. This is the only information they give us. So we got to start with that. So here, 4.070 times 10 to the 6 pounds. And we got to get to kilograms. So to get to kilograms, it would be nice to have grams, because then we could use the 1,000 grams is equal to kilogram conversion factor to convert from grams to kilograms. But we need grams. If we have a pound to gram relationship, we could do that, and we do. So 1 pound is equal to 453.6 grams. And so we could use that to convert pounds to grams. So since I have pounds on the top here, I'm going to put pounds on the bottom. So 1 pound on the bottom and 453.6 grams on top. So pounds cancels out. Now that I have grams, I can use 1 kilogram is equal to 1,000 grams. So let's go ahead and do that. So I have grams on top. So I'm going to put the grams on the bottom. So 1,000 grams, or 10 to the third grams on the bottom, and 1 kilogram on top. So grams cancels out, and I have my kilograms. So I'm done. So now all I need to do is multiply and divide. Multiply by everything on top, divide by what's on the bottom, and I get my answer. And when I do that, I get like 1.8 million. Let's see. So 1,846,000. Let me see. 1,846 and 152. 152 kilograms. So that's the number of kilograms of sulfuric acid used to make Jell-O every year. So I can't keep all of these digits. So remember, my answer should have the same number of sig figs as the least number of sig figs in my measurements. So here I have 1, 2, 3, 4 sig figs. Here I have 4 sig figs. And here, this is an exact relationship, so this we're going to ignore. So the least number is 4. And so here, I can only keep 1, 2, 3, 4. So I got to drop this off. Now, Now, what students are going to be, they want to do is they'll drop this off and then they'll write 1846 kilograms, and there's their final answer. But this doesn't work because notice that this number 1.8 million is much bigger than the rounded answer here. So this is too much of a rounded answer. So you don't want to do that. That's not what you want to do. So whenever you drop off, here's the decimal point here. Whenever you drop off digits that are to the left of your decimal point, you have to replace those with zeros. Otherwise, your number is going to be way off. So we have to replace the 152 with 0, 0, 0. And so this is our final answer with the proper number of sig figs. So remember, there's no decimal point here. If there was a decimal point, if you put a decimal point, then all three of those zeros are significant, and this is no longer 4 sig figs. It's going to be 7 sig figs. We don't want that. So no decimal point. Don't put a decimal point. So here we have, excuse me, here we have 1, 2, 3, 4 sig figs. These zeros are not significant. So here's our final answer. Okay, let's go ahead and do some more problems. Stay tuned. Okay, let's continue with the next 3 problems. So here I have a piece of styrofoam, has a mass of 88.978 grams, and it has a volume of 2.9659 liters. What is the density in grams per liter? So remember that density is equal to mass divided by the volume, which is what is indicated here. So grams is the mass, unit of mass in grams, unit of volume in milliliters, mass over volume. So they want us to find the density in grams per milliliter. So they give us grams, but here they give us liters. We need to convert that to milliliters, so we need to do that first. So we're going to take 2.9659 liters over 1, and we're going to use a conversion factor to convert that to liters. Just like milliliters. So we need a relationship between milliliters. So milli, right? So again, we're thinking about our metric units. Milli is the prefix for 1/1000th of a meter, or whatever the unit is. So milliliter is 1/1000th of a liter. So if I write that here, 1 milliliter is going to be equal to 10 to the negative 3 liters. So I can use that as a conversion factor. So since I have liters on top, I'm going to put 10 to the negative 3 liters on the bottom and 1 milliliter on top. So liters cancels out. And when I calculate this, so basically this is going to end up being 2965.9 milliliters. So now that I have milliliters, let me double check to make sure I got this right. Yep. So here I have grams. So now to get the density in grams over milliliters, I just divide mass by volume. So here I have 88.978 grams, and we divide that by the milliliters here. So I'm going to put that 2965.9 milliliters. Now, there's important to keep track of your sig figs. So when I did this calculation here, I need to know how many sig figs I'm allowed to keep in my answer here before I do it here, before I use that number here. So when I use the conversion factor, this is exact, so I can ignore it. So my answer should have the same number of sig figs as this answer, and it does. The only difference is that the decimal point was moved, so I can keep all of these digits. So now I bring it over here. Now I'm going to divide, and when I divide those numbers, I get 0.03. 0.030000. I think there's 4 zeros and then 3, 4. That's what my calculator gives me. But I can't keep all those digits. So the number of digits here, oh, I forgot the units, grams per milliliter. So now I got to figure out how many sig figs I can keep. So remember that the answer, when you're multiplying and dividing, the answer should have the same number of sig figs as the least number in your measurements. So here I have 5, and here I have 5. So same number, so I can keep 5. So these first 2 zeros are not significant, they're just placeholders. So I have 1, 2, 3, 4, 5. So I'm going to cut it off of here. And so the answer is 0.030000 grams per milliliter. Okay, next. The density of blood, another density problem. So the density of blood plasma is 1.03 grams per milliliter. So they're giving me the density. Remember what I said, when you're reading these problems, pull out conversion factors. Density has a relationship between grams and milliliters. I can use that as a conversion factor to convert between grams and milliliters. So they say a typical adult has 2.5 liters of blood plasma. What is the mass in kilograms? So I need to get the kilograms. But what do they give me? They give me liters, and they give me this conversion factor. So I got to start with liters, right? And what is the mass? That's the end. What is the mass in kilograms? So I need to get to kilograms. So I'm going to start with the 2.5 liters. 2.5 liters of blood plasma. I'll put BP for blood plasma over 1. Now, I have volume here. I need to get to mass. The only way I can do that is if I have a relationship between mass and volume, and I do. However, the units are in grams and milliliters. So in order to use this, I need a volume in milliliters. So I'm going to have to use my 1 milliliter is equal to 10 to the negative 3 liters to convert the liters to milliliters first. So I'm going to go ahead and do that. So liters goes on the bottom. So 10 to the negative 3 liters, and then 1 milliliter goes on top. So liters cancels out, and again, this is liters of blood plasma. Liters of blood plasma cancel out. Now I have milliliters of blood plasma. Now I can use the density to convert milliliters to grams. So now I'm going to do that. So I have grams on top. Here I have milliliters on top. I want milliliters on the bottom. So 1 milliliter on the bottom. So 1 milliliter of blood plasma. And then 1.03 grams of the blood plasma on top. So milliliters of blood plasma cancel out. Now I have grams of blood plasma. But we want kilograms, so I need to convert grams to kilograms. So I'm going to use my metric unit relationship. 1 kilogram is equal to 1,000 grams, or 10 to the 3 grams. So now I can finally, I'll put 1,000 grams on the bottom, 10 to the 3rd grams of blood plasma. And on top, I'm going to put 1 kilogram of blood plasma. Grams cancels out. Now I have kilograms, and now I'm done. I got kilograms here. Kilograms is what I want. So now all I need to do is multiply and divide, and I get my answer. And when I do that, I get 2.575. So 2.575 kilograms of blood plasma. And again, I got to double check to make sure that I have the right number of sig figs. So this is exact, so I can ignore that. Here I have 1.03, that's 3 sig figs. This is exact, so I can ignore that. So I have 3 sig figs. I have 2 sig figs here, so the least number is 2, so I can only keep 2 here. So 1, 2, drop that off. Here's a 7, so I need to round that up to a 6. So the final answer is 2.6 kilograms of blood plasma. So that's my final answer. And then finally, let's do this problem here. If a student drops a textbook on his toe and the signal travels at 18 meters per second, how long will it take the signal to reach his brain 6.0 feet away? So right away here, you got the speed. It's a relationship between meters and seconds. So this is going to be a conversion factor. We're going to use that to convert between meters and seconds, length and time. Okay, we want to know how long. How long will it take? Doesn't give us a unit, we can use seconds. How long will it take? So that's where we want to go. We want to go to seconds. How many seconds will it take to reach for the signal to reach the brain? How far is the brain from the toe? In this case, 6.0 feet away. So that's what we're going to begin with. We're going to begin with 6.0 feet. So the signal has to travel 6.0 feet. How long does it take to travel that distance? So what we're going to do is we're going to start with 6.0 feet. And we need to get seconds. We have meters per second. I have a relationship between distance in meters and time in seconds. I can use this if I have meters. I only have feet, so I got to convert feet to meters. So I got to use some conversion factors to do that. First, I'm going to convert to inches. I know that 1 foot is equal to 12 inches. So 1 foot on the bottom, 12 inches on top. Feet cancel out. Now I have inches. Now I know that inches, 2.54 inches, 2.54 inches is equal, 1 inch is equal to 2.54 inches. So I'm going to put inches on the bottom. So 1 inch on the bottom and 2.54 centimeters on top. So inches are cancel out. And now I can convert that to meters using the centimeters to meters. I know that centimeters, centi means 1/100th or 10 to the negative 2. So 1 centimeter is equal to 10 to the negative 2 meters. So now I can use that as a conversion factor. So centimeters is on top, so I'm going to put that on the bottom. So 1 centimeter on the bottom and 10 to the negative 2 meters on top. So now that I have meters, I can use the 18 meters per second to convert to seconds. So that's my last one. So meters is on top, so I'm going to put meters on the bottom. So 18 meters on the bottom and 1 second on top. So, oops, I forgot. Centimeters cancels out. Meters now cancel out. And I'm left with seconds, which is what I want. Seconds is time. They want to know how long it'll take, so we'll end there. And so now all I need to do is multiply across top, divide by the bottom, and I get my answer. And when I do that, I get 1.8 seconds. And so the least number of sig figs is 2. So I have 2. That's it for this video. I hope you enjoyed this video. If you did, like, share, subscribe, hit that notification bell. Also, put a comment down below. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me. Have a great day.